So my dear student, let us have a beautiful question, that is question number 22. See, I am having a few questions, right, to solve here. It is what? To clear your concept. Now you need to solve the practice question during this preparation of mathematics. Then after you need to solve the previous year questions for your practice. You are getting my point? So this is 3-layer process. First, during learning you need to solve all workbook questions. Second, you need to solve the practice, that means for your practice part. Third, you need to solve the previous year question, so that if there is some another variety with the same concept, you can solve, means you need to solve the previous year question to check whether you are able to solve or not, right? Let us have the question number 22 first. A scalar potential phi whose gradient is given as. So in question number 22, phi's gradient, that means grad phi is given as. So grad phi is given as what? Y z I cap plus x z j cap plus x y k cap. Consider the integral. I am having this integral phi, it is C here, grad of phi del of phi dot dr. Okay. On the curve here x is equal to r is equal to xi plus yj plus zk, so there is no problem. The curve C is parameterized as follows. So the C is what? It is x is equal to t, y is equal to t square and z is equal to 3t square, dear students, and t is varying from 1 to 3. T is varying from 1 to 3, the value of the integral. We need to find the value of the integral. Okay, let's start the game. First of all, if any student, one who don't know whether to apply Stokes theorem, if he want to apply the Stokes theorem, then he can put the answer 0. How? See here. If he want to apply the Stokes theorem, then it is see whether it is closed or not. He is not knowing about the concept, but yes, he is applying the Stokes theorem, I am saying, right? So what is this? This is nothing but gradient of phi. It is nothing but a vector quantity. See here, you can see here, this is nothing but a vector quantity. Gradient of phi is a vector quantity, fine. Now dr, so it is what? Dr. If I want to apply, this is what vector, right? I am writing this. If I want to apply the Stokes theorem, I am saying practically it is not possible, but yes, hypothetically, if the student have a like half knowledge of a Stokes theorem, if you want to apply here, see, he can apply like curl of that vector quantity and ds. Then after seeing this, oh, the IITians frame the superb question, because curl of gradient is 0, so he can put it like 0, but this is what the blunder. Why it is a blunder? Because this is not closed. So how can you apply Stokes theorem, dear students? So please have a good concept so that you cannot apply this kind of blunder in your GATE examination. Otherwise you will realize that we cannot, means you are not, by solving this kind of question, single question, you can definitely demotivate yourself after your GATE examination, right? Let us solve this question. So this is what blunder. Please do not do like this kind of thing. Okay, now let's have. So here I am having the parametric equation. Here t is only varying, my dear students. So how can we change it? Firstly, let us make it scalar, completely scalar. So what is dr? I am writing here dr. See carefully, please drop your pen and see carefully. Dr is nothing but dx I cap, dy j cap and dz k cap. Okay. Now you need to multiply this gradient of phi with dr. Fine. That means this vector function multiplied or dot product with this. So what I am having is this integration c. I am writing directly I into I. So I am having what? Y z dx plus xy This is not xy, this should be xz most probably. Let me check. This is question and xz, yes, xz, okay, xz. So this is a pen error, here it is xz, please write down xz. Here you have a booklet also. So this is what xz, dy plus xy k dot k 1 and I am having what, this dz. You are getting my point? I into I, j into j and k into k. Fine. Now this is our what, the scalar form, and this is what we have done, right? So we do not need to take any derivative. So this is what we are having the function. Now we need to integrate with respect to x, with respect to y, with respect to z, but I am having only one integral and three variable. Only one integral and three variable. You are having only one snake and three variable. How can? It is not possible to evaluate it with the three variable, dear students. So that is why it is given, because if you have a x is equal to t, you can apply dx is equal to dt, fine. If you are having y is equal to t square, then you can have what, dy is equal to 2t dt, and if you are having what, z is equal to 3t square, then you are having what, dz is equal to 3 to the 6t into dt. Fine. Let me check also the parametric equation, t square and 3t square. Fine. Now just put it here. So this is approximately 99.9% solved. I am having this integral, and what is the limit of t? It is nothing but 1 to 3. Fine. And what I am having is yz. So what is the value of y? T square. Put it, all the value can put. So I am having what, yz 3 into t raised to power what, tt 2 to 4, and dx is nothing but dt. You are getting my point? So it is nothing but like this plus xz. So xz into dy, xz into dy. So I am having xz 3t cube 2t, that means what, 3 to the 6t power 4, 6t power 4 and dt, plus last is what, xy t power 3 dz 6t. So I am having what, 6t power 4 into dt. So just solve it. Fine. Okay, I am solving it. So this is nothing but 6 12 plus 3 15 into t raised to power 4, so integration t power 5 by 5. What I am having is 1 2 3. So this is nothing but 3 za. So I am having what, 3 into 3 power 5 minus 1. This will be the answer. Let us solve it by using calculator. You can solve it. Fine, just solve it by using calculator. Just apply it or solve it. Where is the calculator? CAL. Yes. So I am having the calculator, 3 raised to power 5. So it is what, 729. No. It is what, 3 raised to power 5. Just calculate 3 raised to power 5. Fine. And tell me the total answer. 3 raised to power 5 minus 1. So it is what, 3 raised to power 5 is nothing but 27 into 9 minus 1 is into 3. So 726 will be the answer. 726 will be the answer. You have a digital calculator and you can evaluate it very fastly, right? So this is number 22, and please do not have such kind of wonderful thing in your life, right? Let us have the another question. I am having the another question. So the another question is question number 23, and before question number 23 I will just tell you the Green's theorem with this example, and it is asked again in GATE 2008, approximately 8. So I am having the question number 20. I do not need to wipe the board, just have the question number 23. Firstly I need to write the question number 23, so I am writing here. Please bear with me. So this is what, C xy dy minus, write the question in your copy or notebook, right? So this is the question, dy and dx, a square cut from the first quadrant. So let us draw this square here. So I am making the square here. It is cutting the first quadrant, fine. So let us have this square which cutting the first quadrant by x is equal to, okay, is not working, by x is equal to 1 and y is equal to 1. So this point will be what, 1 comma 1. This is what, y x-axis. So here y is equal to 0, here y is equal to 1, here x is equal to 0 and here x is equal to 1. Finally I am having y and this is what, 0, and we should wipe this. Okay. So this is our closed integral. Apply Green theorem and evaluate this double integral. So let us apply the Green theorem. Firstly, what is the Green theorem? My green color is not working. Okay, but let us have the Green theorem. I am choosing the another pen for green color. Fine. So my dear students, we need to apply the Green theorem. Green theorem. Then what is the Green theorem? It is nothing but the scalar form of Stokes theorem, my dear students. Let us have the Green theorem. The statement is nothing but what? If any curve C, which is a closed, forms the region R, if any closed curve C form the region R, then the line integral, I am writing here, the line integral, which is a closed line integral. So this must be closed line integral. You are getting my point? See, it is the closed line integral. Here you can see it is the closed line integral. There is no problem at all. Here you can see it is the closed line integral. Fine. So the closed line integral, this I is equal to closed line integral phi dx minus psi dy, not minus, it is plus, is equal to double integral del psi by del x minus del phi by del y. This is nothing but our Green's theorem. So it is exactly as a curl theorem, dear students, right? It is exactly as a curl theorem. So this is nothing but our Green theorem. So how can we apply? See here, this is nothing but our phi. No, this is our phi and this is our psi. I am repeating, the coefficient of dx is nothing but phi, the coefficient of dy is nothing but psi. Fine. Now let us apply here. I am having the solution here. So I am having what? Minus y square into dx plus xy into dy. See here, xy into dy positive, minus y square dx negative. Fine. Now see here. So let us apply the Green's theorem. So I am having what? The surface. What is the Green's theorem? Del psi by del x. So what is psi and what is phi? This is nothing but our phi and this is nothing but our psi. So del psi by del x minus del phi by del y dx dy. This is what I am using black, then I am writing with the black color. Okay. So I am solving it. S del psi by del x. So integrating with differentiating with respect to x. So I am having what? Y minus del psi by del y. Integration of this. So minus minus plus. Here you can have what? 2. Fine. With this minus sign. So I am having what? With respect to x I am having what? Y, and then with respect to y I am having what? 2y, and into what? dx and dy. We need to solve this. We need to solve the double integral. Then for the double integral in integral calculus, we are having what? The strip. We have done with change of order, right? You are getting my point. Then after you can solve it directly. I am having what? The strip. Let us have RS. So the x is varying from 0 to 1. You can see the x is varying from 0 to 1. Again the y is varying from 0 to 1. There is no problem. So what I am having is 0 to 1, 0 to 1, and this is what? 3y dy dx. So let us solve. 3, 0 to 1, it is what? Y square by 2 dx. Fine. And I am putting what? 0 to 1. Let us solve here. 3 into 0 to 1 y square, that means 1 by 2, so 3 by 2 I am having got 1 and here dx. You are getting my point? So it is nothing but, this solution is nothing but 1, so answer will be 3 by 2. Let me check the answer, but before checking the answer, what is the Green's theorem? You should know, if we are having the closed curve which is forming the region R, then for closed curve phi dx plus psi dy is equal to open surface del psi by del x minus del phi by del y dx dy. For here, this is nothing but phi dx, this is nothing but psi dy. So del psi by del x is nothing but y, del phi by del y. So minus, so you can write here minus, then del phi by del y is what? Minus minus plus. So this is what? Minus, and this is what? Minus 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 plus 3y. So I am having got 3 and here I am having got y. Now what is the limit? So you can see this area, and if you are not able to evaluate the limit, please revise chapter number 3. Please revise chapter number 3 I am saying. So we have done plenty of time in chapter number 3. So this is our answer. Let me check the answer. The option. Fine. So this is what the question. Let me check the option. Option C for question number 23. It is 3, right? Okay. For question number 23, I am having the option C, which is the correct answer. Let me conclude this chapter with the 2 more questions, my dear students. I am having question number 24 and 25. But yes, before question number 24 and 25, please solve practice question number 17 right now. Please solve practice question number 17 I am saying, and apply again Green theorem. You can solve it. Okay, apply Green theorem and solve the pause video question number 17. Then we'll start another 2 questions. Then whole practice question will be yours to solve. Fine. Okay, dear students, I am mapping the board. Pause the video, solve question number 17 of practice. So dear student, for question number 23, the answer is 3 by 2. Now, the question number 24. Suppose C is a closed curve defined as the circle. Okay. So we are given with the circle, that is nothing but unit circle. So normally in GATE examination, the unit circle is very popular, or you can say the unit circle is favorite of our GATE paper setters. Okay. So this is nothing but our unit circle. Fine. Okay. So I am having one here. It is not looking like a circle, but let us suppose it is a circle. Fine. Now the orientation was anti-clockwise. Okay. So always remember why I am taking it. If the default rotation or if the default orientation, is nothing but it is anti-clockwise, because the measurement of the angle is nothing but our anti-clockwise. Fine. The measurement of angle is nothing but anti-clockwise. But if it is given that it is clockwise, then take the integral with minus sign. I am repeating, if it is given it is clockwise. If it is given it is clockwise, then take the integral with minus sign. Then take the integral with minus sign. So by default it is what? Anti-clockwise. That is why I am putting the question in question number 24. So the value of this integral, so I am having this integral, closed integral. I am having C is nothing but our x square plus y square is equal to 1. Good. Okay, and it is nothing but xy square plus x square y. It is asked in our GATE 2017, I think, over this curve. So it is really a 2-second question. Why it is 2-second question? Then why it is 2-second question? Okay, it is with dx and dy. I am sorry, it is with dx, so I am writing here dx plus here I am writing dy. Okay, so no need to put bracket here. Let us have a big bracket. So dear students, why it is 2-second question? Because if you want to apply the Green's theorem, if you want to apply Green's theorem, for Green's theorem I am having what? Integral phi dx plus psi dy is equal to double integral. It should be closed that form the region. So I am having this region R This is the closed integral C, and this is nothing but the region by this curve C, you can say. Fine. And what is the area for this? This is pi r square. That means r square is 1. So pi will be the area. If we use the area, then we can put it pi. But here it is very good question, because del psi by del x minus del phi by del y bracket close dx dy. So dear students, let us see here. This is what phi is nothing but psi. So what I am having, double integral. Okay, see, del phi by del x. So what is del phi by del x? It is 2xy minus the superb story del phi. See, del phi by del x is 2xy. Del phi by del y again 2xy. Okay, and dx and dy. So the moral of the story is nothing but, again it is not working, but I am using green color because I am using Green's theorem. So this is nothing but 0. The answer is 0. So it is a filling the blank question, and the answer of the question number 24. It is Arjun gate examination. The previous months, most not greater than not less than, I mean 2016. After 2016 this question was asked. So let us have the question number 25. Question number 24 is answer 0. Fine. Let us check the answer also. So it is nothing but 0. Okay. Let us have the question number 25, and I will not solve completely question number 25, but yes, I will give you the 90% solution for question number 25. Then we will conclude the answer, because we need to have the calculator. Okay. So let us have the question number 25. The value of the surface integral, and here the surface is open. It is looks like a open. It is looks like a open. 9x I cap minus 2y j cap minus z k cap dot n ds. Okay, over the surface S of a sphere, over the surface S, over the surface S of a sphere. So what is the sphere? A sphere is what? Closed surface. You are getting my point? It is by default what? Closed surface. So dear students, see, in the symbolic representation here it is not closed, but by your common sense, since it is the surface of a sphere, since it is the surface of a sphere, with our common sense we are definitely say that it is the closed surface. You are getting my point? What is the sphere? A sphere is what? Like a football. Football is a closed surface. You are getting my point? It is a closed surface. Now if it is a closed surface, then our thumb rule of gate examination for mathematics is what? Apply Gauss theorem. No need to worry or no need to think anything I am saying. Apply Gauss theorem. So if I want to apply Gauss theorem, then what is the Gauss divergence theorem? Gauss divergence theorem. In question number let me check. In question number 19, you have applied the Gauss divergence theorem. So let us apply in question number 25 also. What is the Gauss divergence theorem? The closed surface integral of a vector point function is equal to the triple or volume integral of divergence of that vector point function. Now we need to evaluate the divergence, my dear students. I am changing the color. Now we need to evaluate the divergence. So what is the vector for which we need to find the divergence? This is nothing but our vector. So let us have this vector. I am having the vector A is equal to what? 9x I cap minus 2y j cap minus z k cap. So let us have the divergence. So what will be the divergence? Divergence is nothing but the del operators dot product. So what is the del operator? Del by del x I cap plus del by del y j cap plus del by del z of k cap dot product with, I am having the dot product with this function. So it is what? 9x I cap minus 2y j cap minus z k cap. So what is the dot product? I am having what? Differentiation with respect to x, I am having 9 minus differentiation of respect to x, y, and differentiation with respect to z. So what I am getting is 6. What I am getting is 6. So 6 is nothing but our 9 minus 2 is 7 minus 1 is 6. Fine. 6 is nothing but our divergence, my dear students. So let us apply the Gauss divergence theorem. I can write the double integral which we need to evaluate, and yes, we have the a here and ds. So it is nothing but our triple integration of divergence of a and dot dv. What is the divergence of a? So here you can see the divergence of a, dear students. D, that means divergence, that means dot product. So what I am having is 6 triple integration 1, because divergence is out, 6 is constant. I am having what? dv, and it is nothing but again the volume. So 6 into this volume is what? Volume of sphere. So what is the volume of a sphere? So 6 into 4 by 3 pi r cube. So this is the basic measurement thing, or this is the basic class 9th 10th thing you need to remember. The volume of a sphere, half a sphere, the volume of cylinder, the volume of cone, right? So this is nothing but our solution, and here the r. So what is the sphere? Sphere is nothing but what? X square plus y square plus z square is equal to 9. That means the radius is equal to 3, because here 9, that means 3 square. So x square plus y square plus z square is equal to r square. So here r is equal to 3, my dear students. So what I am having is 6 into 4 by 3 into pi into 3 power 3. You need to evaluate it right now. I am also calculating it. Let me check the answer also, and also I am calculating it. The answer is what? 678.5. Let me calculate it also, because this is the last question. Because this is the last question, so I need to check, my dear students. Calculator. Where is the calculator? So I am having the CAL. So this is my calculator. Pi is nothing but what? into 9 into 6 into 4. So it is what? 678.85. 678.85. Let me check again the answer. 678.58. Okay, so 5885. So my answer is 678.85 for this question, my dear students. So this is nothing but what? This is nothing but the conclusion of what? Our vector calculus, dear students. So my dear students, let us have the another chapter, that is the maxima minima. The concept of maxima minima will be very easy for you. But before going to the maxima minima, as our rule is what? To solve the entire question from vector calculus, dear students. So you need to solve the vector calculus entirely, then you can go to the next chapter, that is the maxima and minima, chapter number 5. And yes, remember always, I will be giving you the live session also, so please do not forget to miss my live sessions. We will deal some different questions so that we can practice live. So live session is also very important, my dear students. I am not saying that it is compulsory to attend, but yes, if it is free live session in global channel in our app, then definitely you should attend the live session, my dear students. You are getting my point? You should attend the live sessions. It is really important for any subject, you can say. Fine. So now your part is starting, and yes, you are giving with the previous year book, so you need to practice it. Then if you are not able to solve, then please see the solution. There is no problem. If you want to ask me whether I am getting the solution means from where we can have the solution, or if you are not getting the solution means if you are not able to understand by seeing the solution, then you can contact me. I will definitely reply. My WhatsApp number is there, my mail ID is there, the application is there, so there is no worry for doubt clearance, my dear student. But ask genuine doubt, right? And also join the group, so that also join the Gate Academy app discussion, the Gate Academy learning app discussion part, because with the discussion we can have the various kinds of things. For example, you have a doubt, let us suppose you have a doubt. If you posted that doubt and any student X gave the answer, that means there is no problem with it. If you are having the doubt and if you are not posting it, and if you are saying through the lecture I am not getting the concept, or I am not, see, I have given the complete concept, there is no problem at all with the concept. Now the part is what, if there is a different variety of question come in your examination or in something test series or that, then if you are not able to solve, then why not discuss? Please discuss, please put the doubt, please put the question in your, what we can say, Gate Academy learning app, or WhatsApp me, or post in your, what we can say in your Gate Academy mail. There is no problem at all, right? You will get the solution. You will get the solution through the student. 3-step solution you can get, means either you can get through the student, or you can get through the expert, or you can get through me. There is no problem at all. You are getting my point? But yes, if you have doubt and if you are not asking it, then you are a dumb. You are getting my point? If you are having the doubt, then please go to the Gate Academy learning app and put your doubt in the discussion and wait for the solution. And your your doubt is there, just wait for the solution and solve your part, right? I mean, I am saying that with the studies, let us suppose you are solving 50 question, and if you are having doubt in 3 or 4 question, let us suppose, then put that 3 or 4 questions in the discussion mode, and please do not worry for that, and please do not stop your study. You are getting my point? Your study will be going on. This is very important. And just put the doubt there. Discuss with your friend or call me directly. If you are having the panic situation, then please call me. There is no problem at all. My number is, you know my number, and if you are not knowing my number, then definitely please note my number. You can directly contact me, or if you are in the panic situation, then you can call me directly. Please Zoom. So this is Gurupal sir's personal number 7974390037. If you are having any doubt, there no worry, WhatsApp me, or if I am not replying, then directly call me like a big brother. You are getting my point? You can call me directly, there is no problem, but yes, your doubt will be genuine doubt. You are getting my point? Okay, so let's start the another chapter, that is maxima minima. My part is end, your part start. Solve practice question, then you can go for the maxima minima. If you are not solving and you are applying, you are starting the video maxima minima, then you are not my student. You are getting my point? Thank you so much.